Welcome everybody for Solving Systems Part 2. Benny and his buddy Omer love animals and counting. They won an all-expense-paid trip worth $15,000 to Farmer Schultz's crazy counting farm. Farmer Schultz says there are a total of 6 animals, and he said last he counted there were a total of 19 animal legs. If there are only pigs and chickens on the farm, how many of each animal is on the farm? Okay, so first up, we get to put a check mark that we read it. Next up, Benny and his buddy Omer, we're going to do a strike through because we don't need to know that information. Trip worth $15,000? Well, one, a trip to my farm, Mr. Schultz's farm, probably wouldn't cost that much. But once again, it's not something that's pertinent to our situation. We're dealing with there's 19 animal legs, and there's going to be 6 animals. We know that there's only pigs and chickens. Then we know that a pig has 4 legs, and a chicken has 2 legs. So we know that there are 6 animals, and there are 19 animal legs. Okay, so I'm going to put 2 more checks because we read it a few different times right now, and we wrote notes on the side. All right, let's go. So the first thing we have to do is we have to create let statements. So we're going to create our variables. So let blank equal the number of pigs on the farm. We can say let P equal the number of pigs on the farm. Let C equal the number of chickens on the farm. Okay, cool. Now we know if it's 6, there's only a certain number of combinations. 1 pig, 2 pig, 3 pig, 4 pig, 5 pig, or 6 pigs. Same with chickens. Well, it could also be 0 pigs. Create an equation for the total number of animals on the farm. Well, I know it's going to be the number of chickens plus the number of pigs will equal 6. Now, if there's a total of 19 legs, I know it's going to be 2 times the number of chickens plus 4 times the number of pigs will equal 19. Okay, now we're going to be solving today with substitution or linear combination, also known as the elimination method. So here's the substitution method. Isolate for the variable, and then you're going to make 2 equations equal to each other, and then, so you're going to start with 2 variables and get to 1. In each of these examples, we're able to create equations with only 1 variable. The linear combination method right here, we have 2x, and we're going to add these together. Negative 2x, that's going to give us 0 x's. We can see that we go from x and y variables to only a y variable. So in any situation, we're going to go from 2 variables to 1. Now we can't just go and get rid of one of the variables. We have to use mathematical principles, mathematical properties in order to do so. So if we're going to be solving it with substitution, it's tough with more than 1 variable. Both the equations have how many variables? 2. So we're going to let P equal the number of pigs. We're going to say that C is the number of chickens. With the substitution method, it's a way to go from 2 variables to how many? 1 variable. Let's rewrite the equations. C plus P is equal to 6. 2C plus 4P is equal to 19. We're going to use the substitution method to solve this system of equations. And then we're going to check the solution. All right, well, I have C plus P is equal to 6. Let's solve for C. So the opposite of add P to both sides would be minus P to both sides. And I get C is equal to 6 minus P. Now I know that C is equal to 6 minus P. So if I have 2c plus 4p, I'm going to substitute that c for 6 minus p. So 2 times 6 minus p plus 4p will equal 19. Now, what's that called when you're dealing with the parentheses? That's going to be the what property? It's going to be the distributive property. So that means we're going to multiply to both everything inside. So now we just have to work our way to solving this. We understand that we're going to combine like terms. We're going to get p alone, isolate for p. So if we minus 12 on both sides, I should have used red right there. I get 2p is equal to 7. I'm going to divide by 2 on both sides, and I get p is equal to 3.5. All right, so I'm going to take this p equals 3.5 and plug it back into the original equation. Well, one of the equations, the simpler equation. So I know that c plus p will equal 6. Let's go back. 3.5 will equal 6. So if I subtract by 3.5 on both sides, I'm going to get 2.5. So the number of chickens is 2.5, and the number of pigs is 3.5. Well, let's check our solution. Does c plus, so we know that's c plus p is equal to 6. Let's draw that out. We know 2c plus 4p is equal to 19. So 2.5 plus 3.5 will equal 6. That's what it says. Well, 2.5 plus 3.5, 6 equals 6. Yes, that's true. Okay, now we're going to plug in 2.5 for c here. And we're going to plug in 4. Well, no, we're not plugging in 4. We're plugging 3.5 for this. Is equal to 19. 2 times $2.50 is how much? 5. And then 4 times 3 is 12. Half of 4 is 2. 12 plus 2 is 14. Equals 19. So 19 is equal to 19. That's true. What is this? So we've just figured out that both of these are true. Okay, so let's make our real world answer. We will state that Farmer Schultz has 2.5 chickens and 3.5 pigs on his farm. Does that make sense though? This does not make sense because you cannot have fractional number of animals. It's not possible. I mean, they won't be alive. Even if, there was a grave accident and a pig was cut in half, but it still survived, you wouldn't call it half a pig. It's still it's still one pig. All right, let's go on. Yep, let's fix that though, because, all right, let's go on. So now we have solve a system of equation by linear combination. So we're going to solve this problem with elimination. So we know that, let's write it down. We know for a fact that it's going to be 2.5 chickens. And we know for a fact it's going to be 3.5 pigs. Where nothing's telling us like this is the solution. And it doesn't make sense because you can't have fractions. But that's the solution. Let's continue. So both of these equations are going to have two variables. One's going to be p, the other one's going to be c. Writing this out, we know c plus p is equal to 6. And we know that, what was it? 2c plus 4p is equal to 19. So the linear combination method is a way to go from two variables to one. So now we have to try to find a way to combine them. Now, none of these are additive inverses. The additive inverse of 2c would be negative 2c. The additive inverse of 4p would be negative 4p. So we're going to have to change one of these equations in order so that they are additive inverses. So I'm going to change this c plus p is equal to 6. I'm going to multiply by, let's get rid of the c. I'm going to times it by negative 2. I'm going to times this by negative 2. I get negative 2c minus, go back, minus 2p is equal to negative 12. Now I can take the original equation and take the new modified equation and combine them. And if I combine them, I'm just going to add the c's with the c's, the p's with the p's, the numbers with the numbers, and the x's with the x's, and the y's with the y. Just combine like, up and down. Make sure everything is in their place before you add them and subtract them. So if I add this, these will cancel out. This becomes 2p is equal to 19 minus 12 is 7. Now, this looks exactly like how we solved the other ones. Let's look back. Let's go back. Look, right here. We did all this work right here to get to this right here. P is equal to 3.5. Look how much less work that we did in order to solve this. This is one way, an easier way sometimes, to solve a system of equation. It's just a little different, and that's okay, as long as we have our understanding of what this means. So c plus p is equal to 6. So I know I'm going to substitute. C plus 3.5 is equal to 6. I'm going to do the subtraction property of equality on both sides, and I get C is equal to 2p. Not 2p, 2.5. All right. Now, if we checked our solution, it should be the exact same as this one. In fact, I can just select this right here. Let's select this like this. Let's see. Copy and paste. All right, I cleaned it up. So I'm going to input my values for C and P into the equations. 2.5 plus 3.5 equals 6. And then I have 2 times 2.5 plus 4 times 3.5 equals 19. Well, just going through the work, I'm going to see that 6 is equal to 6. And I'm going to see that 5 plus 14 will equal 19 eventually. 19 equals 19. True. So both of these are true statements. So in order to check your solution, how many equations do we have in a system of equation? Well, in this system of equation, we have 2. So to check our work, we have to plug our solution into both of the equations. So what does the solution mean in real life terms? Well, in real life terms, hypothetically, Armstrong has 2.5 seconds and 3.5 pigs. However, you cannot have fractional animals on a farm. You can't have negative, animals as well. Only whole numbers. So in that situation, we'd be like, hey, there's a problem here. And you probably talk to Mr. Schultz, and he'd probably say, oh yeah, dear old Wilbur over there lost his leg. And so then you'd run on the assumption where there should be 20 legs instead of 19. But in all actuality, if you get a fraction as your answer, it's probably not right in most cases. Unless, of course, we're dealing with like money. If you have like 50 and a half, that might be $50.50. All right, guys. See you guys later. And good luck on part 3 of 3. Bye, everybody.